Alright guys, make sure you watch this video before you take the quiz. So before we start, I'm just going to go over the equations that we learned. We learned the force of gravity is equal to gravitational constant, mass 1 times mass 2, over the distance between their center of gravities squared. Alright, good. Now, what else do we learn? We learned that the acceleration due to gravity on any planet is equal to the universal gravitational constant multiplied by the planet's mass divided by the distance to the center of gravity squared. Or, in most cases, it's the radius of the planet. So I'll go ahead and write that right here. Radius of the planet squared. What else did we learn? We learned that orbital velocity is equal to the square root of g m over the distance between the whatever's orbiting, usually the satellite, the distance between that and the center of gravity of whatever it's orbiting. So put a d. Remember, for orbital velocity, most of the time what's going to be is that you're going to find, okay, we need to find d is equal to the height of which the satellite's orbiting, so I'll put the satellite as s, plus the radius of the planet. So d is really equal to the height of the satellite plus the radius of the planet. And so that's going to be your d right there. So just remember that the orbital velocity, the d is usually the height of the satellite plus the radius of the planet. And lastly, escape velocity. Now, I did this yesterday, but I want to do it again today just to reiterate. The escape velocity is the velocity needed so that if you had this velocity, you would not stop until you reached the point infinity. Okay, and we can find it by setting up the law of conservation of energy. Kinetic energy 1 plus potential energy 1 equals kinetic energy 2 plus potential energy 2. At point infinity, these values equal to 0. There's no acceleration due to gravity at point infinity, and there's no velocity at point infinity. So what we're left with is 1/2 mv squared minus mgh. Well, we plug in our g right here. We'll get 1/2 mv squared. I'm going to just move it over to the other side. I'm going to move this over. I'm going to say mg m over r squared h. Now, as it turns out, our h is actually equal to our r, so we can do that. And these two m's are equal to each other, so we can do that. So we're left with 1/2 v squared equals g m over r. From there, we just want to solve for velocity. So we'll say velocity squared is equal to 2g m over r. Take the square root, and we're left with our escape velocity is equal to the square root of 2g m over r. R is the distance to the center. So again, we got this equation right here, this equation right here, and this equation right here, and this equation right here. Now, there's one other thing that might be useful on this test, and I want you guys to look for it in your notes. I want you guys to find Hooke's law. Hooke's law. That might be useful for this quiz. All right. Good luck, everybody.